So we've actually gotten pretty good at programming traditional computer systems. Our desktops and notebooks don't really crash very much, and teenagers are getting rich selling iPhone apps. Surprisingly, though, this is only a tiny fraction of the entire computer market. Most of the computers in the world are embedded deep into microwave ovens and flaps on airplanes. They're called microcontrollers. These things are really hard to program. You have to work at a very low level, and you have to manage resources yourselves. For novices, this is really difficult, and it prevents them from getting started. For experts, it leads to errors. These errors are costly, and sometimes they cost lives. We've developed a system called OWL. OWL is a set of tools and an interpreter, which runs on a microcontroller. You can think of an interpreter as a program that runs other programs. As it's running, it's checking for errors, and it's managing resources. These techniques are nothing new on normal computers, but combined and scaled down to really small computers, they're nothing short of revolutionary. They combine to make programming much, much easier and much, much safer. Finally, OWL is not just a lab project. It works. It works now. We've had 2 years of experience with OWL in the field with real volunteer programmers, and we found that it enables newcomers to program new devices. It enables experts to build systems safely and reliably.
Working with B-spline has been a difficult topic of research for the past 20 years. Now we know that the one-dimensional B-spline is a very useful mathematical tool. Engineers use it to design cars and planes and turbines, and scientists use it to model smooth data. However, researchers have not quite figured out how to extend the one-dimensional B-spline into 2 dimensions. And for our work, we present a 2D generalization of the 1D B-spline, and we call this the biharmonic B-spline. The biharmonic B-spline has many of the attractive properties of the 1D B-spline. Additionally, it is more general, which makes it applicable to even more domains. So in terms of applications, we can imagine using biharmonic B-splines to manipulate images. So these can be extensions to programs such as Photoshop or PhotoWord. In addition, we can model smooth data on the sphere using biharmonic B-splines. So you can imagine modeling temperatures or carbon distributions over the Earth using B-splines. The formulas associated with biharmonic B-splines do not require a lot of computation. This means that it's suitable for implementation on mobile devices such as your iPad or maybe your smartphone. We really believe that this work is opening a new path in working with multidimensional data, and we really invite scientists and engineers to really come check it out and dig around and see